So we are going to start a new unit. So I started trig. We're going to do radian measure today. So a radian is a angle made when we take the radius and wrap it around the circle. So right here is the radian. It's shown in that red right there. It says a radian is about 57.2958, and it goes on and on and on degrees. And typically you use degrees for everyday use, but radians are better for math because it gives us simple and more natural results. I'm going to keep going. This is some stuff from geometry. So just so that you're familiar with the vocab, a central angle is an angle that has a vertex at the center of a circle. So right here's the vertex. This would be the central angle, this angle right here. So this is central angle. Other things that you need to know are arc length. So arc length is the distance along the arc of a circle. So I will highlight that in blue. So this would be the arc length right here. And then the last thing is it just says when the intercepted arc length is equal to the radius, the measure of the central angle is 1 radian. So just something for you to know. Okay, so here's what we're going to do with this. So if you want to figure out a radian measure, this is the formula you would use. So this symbol right here is called theta. It's just a Greek symbol. And that's the central angle in radians. S stands for arc length. And again, that would be this right here. And then R stands for radius. Hopefully you know what a radius is at this point in your math career, but it's right here. And then very important, it says this formula only works if they're in the same units, S and R. If they're not, you would have to make a conversion before you do anything. Finding the radian measure of an angle, it says what is the measure in radians of a central angle that intercepts an arc of length 4 feet on a circle with radius 10 feet. So again, that formula we were looking at was theta equals S over R. So this was the degree in radians. This was the arc length. This was the radius. So we're basically just taking the information they give us and we're going to plug it in. So it says arc length is 4 feet. So that goes where S is. Radius is 10 feet. That goes where R is. And we're solving for theta, which is that angle measure. If you notice, the units are going to cancel out right here. So that's why they have to be in the same unit so that they'll cancel. 4/10 is really just 2/5. And if you wanted to make that a decimal, so this would be 0.4 radians. So when you solve this, you are looking for theta. It says the arc length is 3, so you put that on the top. The radius is 50. These are both in inches, which they have to be in the same unit. The inches would cancel out. If you take a calculator and do 3 divided by 50, you get 0.06 radians. If you want to convert between degrees and radians, there's 2 different formulas you need. It's really the same thing, just flipped upside down. So if you're going from degree to radian, you are going to multiply by pi divided by 180. If you are going from radian to degree, you're going to multiply by 180 divided by pi. So first one says convert 45 degrees to radians. And then it says express your answer as an exact value and an approximate value. So I'll show you the difference. So if we're going from degree to radians, you're going to multiply by pi over 180. So I'm going to take 45 times pi over 180. Remember, when you multiply fractions, you multiply straight across the numerator and across the denominator. So I would get 45 pi over 180, and I believe you can simplify 45 over 180. Would be the same as 1/4, so you would really have pi over 4. So this is considered the exact value. If you want an approximate value, you would actually take pi and divide it by 4. So pi divided by 4 is approximately 0.7, let's go with 9. So this would be considered your approximate value. Okay, it looks like most of you were getting that correct. So you would have 60 pi over 180. If you look at 60 over 180, that's really just 1/3. So pi over 3 would be the answer. I'll just do one of these. So I just want to point out, notice that 472 is a really, really big degree value. You just do the exact same thing. So you take 472 and you multiply it by pi over 180 to switch it to radians. So even though it's a large value, you're doing the exact same thing. It looks like the simplified fraction would be 118 pi over 45. It's kind of a weird value, and the approximate would be about 2.6 pi. So we'll go ahead and skip this part here. It would be the same process. Okay, lastly, if you're going to convert between degrees and radians, but we're going the opposite direction. So we're going to convert 2 pi over 3, so this would be a radian because it has no unit listed, to degrees. So this time we're taking 2 pi over 3, and we're going to multiply by 180 over pi. When we do that, our pi's cancel out. We have 2 times 180, which is 360. And then 360 divided by 3, which is 120. So this would be 120 degrees. When you do this one, you have 3 pi over 2. To convert to degrees, you're going to multiply by 180 over pi. Your pi's cancel out, so those are gone. 3 times 180 is 540. 540 divided by 2 is 270, so 270 degrees.